So first is our contextual applications of derivatives. So what is a derivative in context? We have lots of stuff with average rate of change. So if you've got the function, you can find out how much your y changes, that's your rise, how much your run changes, that's your change in x. Your average rate of change comes up a fair bit. And your derivative is that instantaneous rate of change at a specific point, okay? Which is the slope of our tangent line. We've seen lots of this. Some of the things that we're going to do is straight line motion, connecting our position, velocity, and acceleration. We know that our velocity is the derivative of our position function. Acceleration is the derivative of a velocity function, which means that acceleration is the second derivative of your displacement function. Okay, a couple things that come up. If velocity and acceleration have the same sign, either both positive or both negative, it's speeding up. So you'll get some questions that are going to say, hey, is the particle speeding up or slowing down at this point? That's telling you have to check for both velocity and accelerations, right? If they're the opposite sign, then it's slowing down. Velocity is negative. Something's moving to the left. Velocity is positive, it's moving to the right. Anytime your velocity is equal to 0, your particle is at rest. Okay? And speed is the absolute value of velocity. Rates of change. When a quantity is increasing, its rate of change is positive. When a quantity is decreasing, its rate of change is negative. If you're dealing with the rate of change, or if you're dealing with the rate of change or a rate of change, it's the derivative of f prime of x. So this is where, like a little bit, we have, if you found some point C where it's at rest because your derivative's equal to 0, and you found out f prime of x was positive here, that tells you that f of x is increasing. And anytime you find out f prime of x is negative, that tells you that f of x is decreasing. And this is true moving up one level no matter where you are. So later on, you might get a number line that has your second derivative. And you might have a point C on there where your second derivative is 0. And you found out this was positive and this was negative. Moving up one level, you would know that f prime of x was increasing, f prime of x is decreasing. Because every time you move up one level doesn't necessarily have to mean f prime to f. It could be f double prime to f. That's moving up one level. Moving up two levels, right? Here, this would tell me concave up. This would tell me concave down. And I find drawing these charts and knowing where you are on the chart can be very helpful for analyzing questions that are otherwise somewhat confusing. Related rates. So I don't know if you heard in the videos that we've been watching lately, related rates don't come up on long answer questions. They come up on multiple choice questions. So what do we have to know? Identify what you know and what you don't know. Write an equation that involves the things that you know and don't know. Take the derivative with respect to time of both sides. And we'll do some questions like this. Then you can plug in things and be sure that you use units. And some other things that sometimes come up with related rates is, let's say I have some function, and I'm going to use different letters. Let's see, what letter do I want to use? Big M of little r. I don't know. We have some equation, big M of little r, the mystery equation. I'm not sure. Well, if you had this, derivative-wise, does it make sense that you could find dm dr based on the variables that are there? Okay? And sometimes they'll tell you something else like, oh, we'll tell you what dr dt is. Can you find dm dt? And you're really confused because you don't have an equation with m and t in it. Okay? But we can put these things together and say, well, dm dt will just be dm dr times by dr dt, because technically it's like these cancel out and they're the same thing. But sometimes in related rates, you can put things together that way and solve equations that you might not have known. Okay. Approximating values of functions using linear approximation. This comes up a fair bit on exams. You can grab one of those. This is the first. Linear approximation is basically using the tangent line to approximate something. You guys are good at finding equations of lines. What do we need? We need a slope and a point to find any equation of a line. If you want to find an equation of a tangent line, well, your derivative finds you your slope. And usually the point is given. And for the most part, it's really easy to use this form of the equation of the line for linear approximation. And then they ask you to say, well, if you use this line, can you approximate x at a certain value? We'll get to some questions like that. And usually it makes sense not to simplify this, just plug things into here. Because the point that's given, so let's say the point I had was 1, 3, and my slope was 2, so my equation would have looked like this. If you're going to use your tangent line as approximation, chances are they're going to give you an x value close to the point that you're given. The closer it is to that point, the better an approximation it will be. So if I ask 1.1, well, I'll plug it in here because then this simplifies to be a pretty small number, and then I'd simplify after that. But we'll see some questions with that in our examples. L'Hopital's rule, super important. Again, a couple of things to be careful on the exam not to do. Right? Here's an example of one where I could use L'Hopital's rule. If you have infinity over infinity, something like this. Okay? The bottom goes to infinity, the top goes to infinity. Or if you have 0 over 0. The important thing to not do is write equals infinity over infinity. No. They'll take off marks for that every single time. Because this limit is equal to something. Maybe it's infinity, maybe it's a number. But you can write in brackets, indefinite form, infinity over infinity.
So you can write it, but you have to put in brackets and like don't.
As long as you don't write the equal sign.
Okay.
You can write infinity over infinity, or you can break it down and you can show the limit as x goes to infinity of e to the x equals infinity. Well, that's a bad infinity. I don't like it. And you can show the limit as x goes to infinity of x equals infinity. That's fine. You can show the top separate and the bottom separate, and then have indefinite form.
What if you wrote like the limit and then you put in the infinity? So you said limit as x approaches infinity of e to the x over x equals e to the infinity over infinity equals indeterminate form.
No. Because this isn't actually a thing, right? So as soon as we put equals there, it has to be equal to what it actually is. And as soon as you do that and it's not equal to what it actually is, it'll be like that's an algebraic error.
What if you skip that part and just put equals indeterminate form? Like, do you have to just put it on the side?
Just don't put equals.
Don't put equals.
Never put equals.
I wouldn't put
It's so
equals
ugly.
Just put brackets and be like.
indeterminate form off to the side, or you could do this. Therefore, indeterminate form.
That's too much.
That's a lot of work.
That's what I know. I don't like.
What?
So just off to the somewhere where you know it's indeterminate
That's
form.
what I got.
So we can use L'Hopital's rule. Then, when you use L'Hopital's rule here, you take the derivative of the top and the derivative of the bottom, and then this one you can say, now I know that it goes to infinity. Okay?
Yeah.
You can't use L'Hopital's rule if it doesn't follow that form. And it doesn't happen very often, but every once in a while they put one on there that it's tempting to want to use L'Hopital's rule. And it's actually, no, you can't do it here. Not allowed.
We're totally gonna get one of those. Yeah.
All right, so let us, I find that taking actual questions helps us see things better. W is a differential function that W of t represents the amount of water in gallons after t hours. So here, what is the best interpretation of W prime of 4 equals 3? First of all, what is W prime of 4? That's a rate of change. A rate of change of water at t equals 4. So when we go through the questions, A is an amount of water. You could already say no to A. An average amount of water? No. This is a rate. We can already say no to D. Now, both B and C use the word rate, so let's read them more carefully. The amount of water in the tank is increasing at a rate of 3 gallons per hour. Well, this is the rate, so this matches up. Is it increasing? How would we know? Okay. Okay, or the rate of change of the amount of water in the tank is increasing at a rate of 3 gallons per hour. So what's increasing? Is the water increasing, or is the rate of change of the water increasing? The water is increasing. Why? Well, if W prime of 4 is bigger than 0, in other words, it's positive. Think about your charts. Anytime you have it positive, moving up one level means that's what's increasing. So the amount of water is increasing, not the rate of change is increasing. And the answer is B. Pineapple questions. P of t represents the rate at which pineapples are shipped by a distributor, measured in pineapples per week. After t weeks. Which of the following statements would justify that the number of pineapples being shipped is increasing? So what happens? What has to happen for the rate for if you move up one level for it to be increasing? The rate has to be positive, right? So if that rate is positive, then
Oh, it is already there.
so P of 4 is bigger than 0. Up one level would be the pineapples, and they would be increased. If P of t was the amount of pineapples, then you would have to see that P prime would be bigger, right? But this is where we have to make sure we read the question carefully. Model for velocity of a particle moving along the x-axis, v of t is given in the graph above. On which intervals is the particle moving left? You're thinking D?
Yeah.
Velocity is negative in D. And if the velocity is negative, it's moving left. So the answer is
Okay, that's easy. I just got it so fast. It's like, thank you for backing me up, though.
particle moves along the x-axis at time greater than 0, and its velocity is given by 2t squared minus 6t. Which of the following statements describes the motion of the particle at time equals 1? So sometimes in these kind of questions where I'm like, okay, what am I wanting to solve? And I quickly skim through the answers that are there. I see a lot of speeding up, slowing down. So that makes me think, okay, I'm going to need to check velocity and acceleration. So if I check my velocity at time 1, I get -4. My acceleration, which is the derivative, at time 1 is -2. And what does it mean if your velocity and your acceleration are the same sign?
Speed.
It's speeding up. So the answer is A.
It's like two.
I'm so upset. I didn't manage the question.
So just going through these, what would we have to get answer B? 1 positive, 1 negative. What would you have for part C?
It's not moving.
Not moving or staying the same speed,
Yeah.
right? At a constant speed. You're not speeding up, so then the acceleration would have to be 0 to get C. Okay? And the particle at rest, how do you know if something's at rest? Velocity is 0. So just, sometimes it's neat to go through the multiple choice and say, they could give me the same question, how would I change it so that I get the other answers? And this one, I think, neither speeding up or slowing down to see the acceleration is 0 is a little bit harder. Doesn't come up as often. A block of ice in the shape of a cube melts uniformly, maintaining its shape. The volume is given by the formula, volume equals s cubed. At s equals 2, the volume is decreasing at a rate of 5 cubic inches per minute. What is the rate of change of the side length of the cube with respect to time in inches per minute at that moment when s is 2? This is definitely a related rates question. So how do we set up our related rates question? We look at our formulas. We look at what we know. We know that at s equals 2, dv dt is -5. Once you have your formula, you can take ddt of both sides. And our job is to find ds dt. So ddt of v, dv dt. ddt of s cubed, well, that would be 3s squared ds dt. So this is implicit differentiation. What do we want to solve for? We want to solve for this. We know all of the other things. At s equals 2, the dv dt is -5. Some common mistakes that I sometimes see students do in a question like this is they want to plug the 2 into the s already and just say, okay, v is equal to 8. That was just a moment that we know at s equals 2, these things are happening, but throughout the rest of it, the s is changing, the volume is changing. Both the volume and the sides change with respect to time. And then it's just a matter of rearranging and solving, so the answer is A. So I find these ones are, what do I know? What do I want to find? What's my equation? Take my derivative of both sides of my equation, and only after I've done that, then I plug things in that I know. Another related rates question. The radius of a circle is decreasing at a constant rate of 2 centimeters per second. What is the rate of change of area in square centimeters per second at the instant the radius is 5 centimeters? So we know that radius is a function of time, area is a function of time. What do we know? We know the dr dt is -2. We know the radius is 5. We want to find dA dt. Now, can we create a formula? Yes, this is a circle. So your area of a circle formula is pi r squared. We take dd dt of both sides. And then we can just plug our values in. Sometimes the hardest thing in a related rates question is knowing how to come up with a formula that relates the things that you're working with. This one was relatively easy because it was a circle. But sometimes some of the shapes, do we remember the formulas? F of 2 is 3. F prime of 2 is -4. What is the linear approximation? And so at this moment, when I see linear approximation, I think I want to find the equation of the tangent line and plug in that point. What do I need for an equation of a line? I need a point and a slope. Well, they gave me the point is 2, 3. They gave me the slope is -4. Y minus y1 equals mx minus x1. And again, your life will be easier if you plug it in right away, because then you're going to deal with smaller numbers. 2.1 minus 2 is just 0.1. 0.1 times the 4 will be 0.4. Then I just have to deal with 3 minus 0.4, and I get 2.6. My answer is A. So if we remember that linear approximation is just using the tangent line, how do you find a tangent line? You need a point and a slope. Once you've got that equation, then you plug in your number. If the line tangent to the graph is used to estimate, so we have linear approximation once more in this one. What do we need? We need that equation of that tangent line. And in order to get that equation of that tangent line, we need a point and a slope. So our point, we plug in 3. We get natural log of 1, which is 0. So we now know that our point is 3, 0. To get our slope, we need our derivative. Tiny little chain rule here. And we want to find that slope specifically at 3. So we plug in 3, and we get a slope of 2. Once you have a slope and a point, plug it in. And again, I would plug the 3.5 in before I distribute. 2 times a half, we get 1. The graph of f of x is shown above to consist of 2 semicircles and 2 line segments. What is the value as the limit as x goes to 4 of f of x over x squared minus 16? So quickly, I just plugged in 4 into the bottom. I noticed the bottom when I plug in 4 is 0. I'm like, ugh. But it also makes me think, well, maybe I can use L'Hopital's rule. What is f of 4 on the top if I plugged in 4? F of 4 is also 0. Now you could show this work, that the top is 0, the bottom is 0, therefore the indeterminate form. And therefore we're allowed to use L'Hopital's. Me personally, I would be like, show that it's indeterminate form and then make a little bit statement so we can use L'Hopital's. Then I do the derivative. Now when I plug things in, the bottom is 8. So I can't use L'Hopital's rule again. Can I find f prime of 4? And it quite often happens on these questions that you're like, I don't know how to take the derivative of this squiggly graph, but they often give you the derivative of a straight line segment because you can figure out the slope of that line segment. And if you recognize that all a derivative is the slope of a tangent, and anytime you have a straight line, it's just the slope of that straight line. That straight line slope is -1. So our answer will be C. However, this is multiple choice. So if you want to, because it's multiple choice, you can use all the bad notation you want. You can go equals 0 over 0, ha 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 ha. You can't take any marks off me right now. And it's going to be karma, right? If you start messing with the exam, it's gonna karma. They're gonna come back and get you somehow, right? But yeah, for multiple choice, how you write the work doesn't really matter. But we'll try to practice it the right form all the way through. If a single application of L'Hopital's rule can be used to evaluate this, and is a finite number, one of those has to be false. Okay? Could the top be 0?
Yeah.
Yes, because L'Hopital's rule is either 0 over 0 or infinity over infinity. It doesn't have to be true, right? Because it could be infinity over infinity, but it's not for sure false. Okay? Same thing with g of x. Well, if I can use L'Hopital's rule, then I would get this. And apparently, I can solve this. Now, if I can solve this, could the top be 0? Would that, yeah, I guess it could be. Could the bottom be 0? Because if the bottom was 0, then I couldn't solve it, right? Therefore, that must be false, and the answer is D. So again, this part here should tell you to write out this right away. And then go through these things. Yeah, there's a test question on here, eh?
Yeah.
Yeah, which is what going through old exam style questions and then trying to pull, like in the longer questions, what are the little parts that are just this unit? And we have that one question.
Oh,
from.
no. Oh my god.
Okay, we can skip it. We can skip it.
That's.
Yeah,
That's
so rough.
The model for the velocity of a particle moving along the x-axis is given by v of t. What do you need for a particle to be at rest? Velocity of 0. Does that ever happen on this graph?
Yeah.
It happens at 3 and at 6.
Tough question.
So the answer is C.
I can't talk now this question.
You want to skip this one?
It's only one part.
I wanna see.
You want to see how it's done? Well, we're only doing one part of it. Right? Because so
It's like the easiest part.
this is the easiest part. Yes, you've got your G and T. You should plug that into your equation. So you can just plug that into your calculator to get this. However, it's important that you read the question. Interpret your answer in the context of the problem.
I did that. I didn't do the part right next to it.
Okay? So in the context of the problem, so what do we need here? We need to say at t equals 5 hours, this is a rate. It's a rate of what? It's the rate of gravel arriving at the processing plant is that negative 24.588 tons per hour means that it's decreasing. So that when it says in the context of the problem, we have to use the words in the problem, use the units. Tons per hour would also be fine. My class will go over the test tomorrow.
You guys haven't gone over it?
No, the last person wrote it today.
What was the average on your guys'? No, see.
I didn't calculate the
Our
average.
average was
Oh, sorry, I'll put it back up.
I'm pretty sure that Ross our average was like.
He said it was somewhere in the 70 range.
Yeah.
7 it did not.
I thought
70.
70.
He said that was like the people who should get that over.
You didn't put in.
I think he did. That's what all the notifications are about. That's why our phones are busted. Oh,
wait, what?
My grade dropped 112.
My grade 7.
What? Did you fail?
Is that from the bump?
I don't know.
Yeah, it's probably from the bump.
So your class average was 70, 80, so Jesse'd say ours was probably like 80 to 90 then.
Oh.
Oh, he did take the bump off. That's
I
why.
got getting 50.
Oh. My bumps went off.
All good?
Yeah, my bus went off.
Yeah. Okay, so that's what it was.
Yeah. Bella, we got 1
Three
point more.
courses?
He put that bingo in.
Oh, he put the bingo in.
The particle moves along a straight line from 0 to 5. The velocity is given by that equation.
It's over. It's over.
And the position
You know, we're not getting that.
is given by s of t. You know that its original position, s of 0, is 10. Okay? Find all the values of t from 2 to 4 for which the speed of the particle is 2. Speed is what?
Velocity.
Absolute value of velocity. Now, if you're given a question like this on the exam, first thing you would do, especially when it has A, B, C, and D, we're just going to do A and C because it's related to this section. You're going to type that into Y1. Okay? Because you're probably going to be able to use it for multiple times. with that in y1, and you know that the speed is the absolute value of t, you need 2 to equal the absolute value of t. So if I had in my graphing calculator, in y1 I had this, in y2 I would do the absolute value of y1. Do you know how to find the absolute value signs?
Also,
Under math and then move over to number. We can show it right here, right? So if I had, like, if that was my y1, which isn't my y1 that I had in there, but I can go math, I can go over to number and hit that absolute value, and then
In the graph. Oh.
I can do y1 in that, having typed in the right equation into that. And then, yeah, things are going good. And then here in y3 I can put 2. Did you know that you can turn on and off graphs by pushing enter on the equal sign?
You're turning on things and not turning them on.
Whoa.
So if you unhighlight an equal sign, it turns the graph off. On Desmos, you can click the little symbol beside and it turns on and off the graph. So this would be also quite nice to solve in Desmos as well.
What's available?
It's an option. No.
Wait, how do you?
No, you
We
have
just
to.
we're walking into desk. We're walking in.
You can use both. You can use Desmos and your calculator. Not like
I would. That's.
I need to go. My pickle sack. That's not my favorite
And from that, you would just get these times.
They're on Boston.
Okay, so it's
Those are the
It's like the
intersections.
OG calculator. First calculator.
Thank you.
Okay? As soon as I finish this question, I reread the question just to make sure there wasn't any units. Okay. Because you kind of feel like you wrote a time, you should write hours or seconds or minutes or something. But rereading this one, no units are given. What do we need for the particle to change direction? We need v of t to equal 0. And then it also needs to change from positive to negative or negative to positive. So it must change signs. And it must equal 0. Those are the places where it's equal to 0. And then we do a check. It changes from negative to positive. Now they won't see your graph. They won't see your calculator, so you do need to, it's not just enough to say the velocity is equal to 0. Because in order for it to switch directions, it also has to change sign. And you check at 3.318. And there your velocity graph goes from positive to negative. So it's also changing direction at that time. So one of the things I'd recommend, like you're doing your exam, and you might get to the point where at the end of the long answer, you've got some time, you're going to check over your marks, check over your work. That's when I would look at, okay, are there those little details that I should add a little bit more of an explanation? And sometimes, right, stating that the velocity changes from negative to positive and positive to negative might be an extra mark in each of these that you could lose out just because you saw it, your brain said, yes, I know this is the answer, but they don't see your calculator, so we need to explain that.
Would we ever get marks taken off for putting approximate signs instead of equals?
No. I don't think they, like, I mean, I'm not the marker, but like,
if we put equals
like
instead
the
of
answer is
approximate.
13, you're saying that if x is equal to 13 over 7 and you accidentally did this,
That was not.
No, the other way around.
the other way around,
For the t equals,
Like, you
like
want-
if you put t equals 3.318, They get mad at you.
No. IB used to, the IB courses used to get mad at you, but I've never seen the AP have a mark allocated to the symbol,
This is the first year that they're gonna do that.
okay? But,
Only to
Just
me.
for-
okay, make sure you have 3 decimal places, because going 0.54 isn't accurate enough.
You lose all your marks.
All your marks, they just like, another test we don't have to mark anymore.
They won't even mark
I
yours.
hope they do have that, like, a little capability to-
It's like when you go for your driver's test, right? You hit the curve on the parallel park, they're like, we're not even going out
Did not
anymore.
hit the curve very
It's
well.
done.
You hit the curve today.
When I was getting my driver's test, I had a friend
This is fine.
who failed his driver's test twice before even starting the car.
No.
Wait,
Oh.
you did not buckle up or something?
He did not buckle up.
Wow.
That was one. He put the key in, turned the ignition, they're like, turn it off. You're out of here. First time he came, and his parents hadn't updated their license and registration, so the car was actually illegal. So they're like, we can't go on the driver's test because I'm not allowed to take you out in a vehicle with no insurance. So he failed the first time because of that. Second time, no seatbelt.
And you reverse
That's wrong.
on your curve. They still let you go out.
We almost like that at mine.
Is the speed. Okay, so speed makes me think of velocity and acceleration.
Your car's too.
Velocity is a -11. Acceleration is -12, -22. They're the same side. So just a little explanation of that.
Guys, I'm not making you go something about it.
I'm on the board.
Already done.
Yeah, I can't type the, we didn't type the bell actually. Wait, I didn't, I did not. I don't know if that was the thing, but why?
I just started my.
It's a round.
Look at you guys.
What's the bell?
Oh yeah. Okay. It was like, oh, sorry, progress. And then that for me.
And I'm not gonna.
I was super disgusted.
I think that makes the most sense.
Okay.
And then this one.
That makes sense.
Very good. Okay.
Or Grizzly.
My name.
Don't you get scared by the questions when they have this many words?
Yes.
Yeah.
I only look at the numbers.
Just look at the numbers.
Yeah.
All right. I will.
I just started looking, I just started writing stuff.
So for you, this question looks something like this: 0, 91, 0, 27, 0, 27, 0, 91.
Yeah.
Yeah, pretty much.
That's not all you need.
You just look at what's attached to numbers and that's all.
Oh, what? No.
Read the
Yeah.
question and then you go back and look for parts of it.
Okay.
Instead of like.
Boiled potato taken from a pot on the stove and left to cool in a kitchen.
There's no.
Internal temperature of the potato is 91 at time equals 0.
Oh, I think it's that.
There's like one thing you
I see the question. It's literally just.
Because it just came out of the oven. It's super hot.
This is it.
You think that's cold?
Have you never played hot potato? The internal temperature of the potato is greater than 27 degrees for all times t greater than 0. And the internal temperature of the potato at time t minutes can be modeled by the function h, which they don't give us, but they give us the differential equation h of t equals -1/4 h minus 27. This is nice of them to say h of 0 is 91 because they already told us that up here. It's just a repeat. Write an equation for the line tangent. How do we find a tangent line? We need a point and a slope. Okay? at t equals 0. Do you see that we already have the point?
The easiest form of equation.
We have the point, but we need the slope. How do we find the slope? We use the derivative and we plug at t equals 0. In the derivative though, it has h. H is 91 when t is 0. So that's kind of an interesting, you're like, I don't know how to plug in 0 for t, but you actually plug in the h value and get negative 16. There's our equation. You could plug in 3 and get 43 degrees.
Could I just leave in y equals 91 minus 60?
You could.
And write degrees Celsius.
And then degrees Celsius. But I do find
Okay,
when you leave it like this, you have to be careful that you don't go, haha, I don't have to simplify, and then you forget the units, right?
I'm practicing math, so
So-
no, I will not be doing any unnecessary arithmetic.
We want to be necessary.
I don't. Just cut out the middle now. Oh yeah, which is math.
No.
Are you even? I don't know. That's a good question.
Something to be careful of and pay attention to is if you start reading first the function f, your brain might automatically assume this is the graph of f. Okay? Be careful that you're making sure, oh, this is actually the graph of f prime. Okay? Defined on the closed interval, negative 2 to 8 satisfies that f of 2 is 1. The graph of f prime has 2 straight lines and a semicircle. Find this limit. Ooh, that doesn't look very nice. Can you quickly plug in 2 on the bottom and see that it's 0 on the bottom?
Do I actually have to show me doing that, or can I just write 0 over 0 in form graph?
You can't do it.
I didn't write equal and say 0 0.
Just pretend.
Like, do you have to write these parts?
Do I actually like have to?
Like,
Whoa! Do I have to show me putting it in, or can I just bracket write 0 over 0 in
In
form?
indefinite form, because it's 0 over 0, that would probably be fine.
I don't have to really show that I did it.
Probably.
Probably, maybe actually.
This might be 0.
Yeah. Just do it.
Well, babies can do that. Wasting my time. I'll be down to the wire anyway.
Take the derivative, then you can plug things in, and f prime of 2, look at, it's on a straight line again. So that you could just find the slope of that line at 2 to find out.
Yeah.
Oh, that's already f prime. Whoa. See what I did, what I said? Be careful not to do. This is already f prime, so f prime of 2 is just that point. 2 comma 0.
We have an agent.
Calculus
Calculus modifier. I will I said.